Hello, welcome to my presentation. My name is Jeremy Chu and I'll be reviewing the problem a ball rolling down an inclined plane. Now, the problem we are discussing involves a uniform sphere of mass m and radius r being released from rest on an inclined plane. Now, the diagrams here from left to right show kinematic, free body, and kinetic interpretations of this problem. In this problem, we are interested in finding the normal force, friction force, and both linear and angular acceleration and velocity. Now you may ask yourself, how do we solve this problem? Well, there are two methods. One is manually with a calculator, pen and paper, or we can use MatLab, a computer program by which there are two methods. The first being Newtonian, which is considered a simpler in code, but can only solve problems with no slip conditions, or we can use Simscape, which is more complex in code, but can solve problems with both non-slip and slipping conditions. Now, before we divulge into any complex calculations, it's important to discuss any parameters we use. So, on the table on the top in orange, we see the boundary conditions, range of values, which we have to choose from. On the table at the bottom, the blue one, we can see the values we had chosen in the end, including the mass and radius of the sphere. I'll also discuss the fundamental equations which we'll be referring back to in calculation. So the first one being sum of forces in the y direction, where we get normal force, sum of forces in the x direction, where we get friction forces, and the sum of moments about point A, which will give us an equation to help us solve for acceleration. An important principle to discuss is the no-slip condition, which states that the friction force will be less than or equal to the static friction force. If we assume this to be true, we can prove this inequality using our fundamental equations, where if shown to be correct, we can continue to find velocities and acceleration. The opposite of this is the slipping condition, where if the inequality is not true, friction force is equivalent to the kinetic friction force. Using this in conjunction with our fundamental equations, we can then find acceleration and velocity. Here we have our calculations which disprove the no-slip condition, giving us the following results. I'll briefly discuss how the MATLAB calculation was used. First, we input the model parameters which were then fed through functions with both Simscape and Newtonian methods being utilized, the results of which were then displayed graphically, which can be seen here in the MATLAB results, with the orange being the Newtonian method and light blue showing the Simscape method. Comparing both manual and Simscape solutions, we can see that both are identical, which verifies my manual calculations. Thus, in conclusion, for all practical purposes, Simscape finds solutions the same as a human would manually, which is very good for verification. However, calculates more efficiently.